So for those who may not be familiar with the Open RAN, it is a technology that's been gaining a lot of attraction in the telecommunication industry over the past few years. Okay, so Open RAN is all about breaking down the traditional closed and proprietary systems that have dominated the industry for like decades. And instead of building open and interoperable networks that allow for greater innovation and flexibility and cost effectiveness. Okay, so for today, we will be discussing about the radio access network. So this will just be an overview for you to understand more what is an open RAN and for you to like appreciate more of what this technology can bring over the telecommunication industry. So I think without further ado, let's start. So the topics that we'll be discussing today will be first is the radio access network. Next is, of course, an introduction to the radio access network. The wireless telecommunication system, the electromagnetic spectrum, and some key learning points of or the summary of our discussion. Okay, so to set the stage, let's start with a brief overview of what RAN is and its role in the telecommunication ecosystem. So now you will see on your screen a map. So if you know a cell sites, I know that you already saw a lot of cell sites around you. So these cell sites are strategically placed across a geographic area to ensure that your mobile devices within the network's coverage area can connect to the RAN and access network services. So you can see in the photo, there are like different colors, different types of technology. You can see on the bottom right. So let me wait. So here, these are the technologies that we have in order for us to stay connected. So the RAN connects mobile devices to the network. So it offers mobile network coverage. So take a look and observe. So each technology corresponds or have a color coded system. So it represents the technologies that is present in a certain location. So here you can see that there's a lot of 4G coverage in a lot of areas in this in the map. So that might be here in Cavite, Marikina, Quezon City, and Balanga, and a few 5G coverage. But I think this time as of today, there are already a lot of deployed 5G technology in the country. So this was a 2020 update. Okay, so yeah, that's it. So next. So let's break down the radio access network. So just like what I've said, it is strategically placed to provide a wireless coverage within users' geographic area. So this RAN, it gives signals to us for us to stay connected. And the RAN components, such as these cell sites, it is critical that users have reliable and consistent access to the network services they need. So when planning the deployment of the RAN, so the engineers, network operators, telecom providers, network designers, uh, really, really consider a lot of factors when planning where to put these cell sites. So here, there are a lot of cell sites that is really around the Philippines. So by analyzing for example of these factors is can be population density, topography, building density, traffic patterns within a coverage area for us to stay connected. These um various factors um need to be considered for so that there will be a minimal attenuation so that there will be less interference within each cell site. So the RAN elements create seamless coverage and mobility. So, like for example, if I am an engineer, if I am planning for it, within like in an urban areas or in a city, in a city, we have high population density and building density, so there will be a lot of interferences. So what do network operators do? So they need to deploy more cell sites with lower output power to provide coverage to smaller areas. So that's the logic behind it. While in the rural areas, there are only lower population density. So network operators needs to deploy fewer cell sites with higher output power so that they can cover or provide network coverage to a larger area. So that's how we plan, aside from the factors that I said earlier. So the placement of these RAN components also affects the overall network performance, such as the call quality, data speeds, and network capacity. So there's a lot of things to consider, but the goal is to give the users an optimized network performance so that the operators can ensure that they have a high quality and reliable network experience. So now moving forward, this is the wireless communication system. So this network is composed of three main parts. First one is the user terminal. The second one is the radio access network. And the third one is the core network. So first is, again, the user terminal. So what is a user terminal? So basically, the user terminal are the devices used by the end users. What I mean by the end users is us, you, to connect to the radio access network of a wireless telecommunication system. Like, for example, these are your phones, these are your tablets. So these if your gadget or your device is a 2G capable device, it is called a mobile station. And if your gadget or device is a 3G, 4G, or 5G capable device, it is called a user equipment. So like if you're talking with your co-engineers, you can like say that, oh, let's buy a new user equipment. So and normal people just call it cell phones. Okay. So next one is we have the radio access network. So the radio access network is kind of like responsible for providing the wireless connectivity required for mobile devices to connect to the core network and access these services. What I mean by services is calling, data, and texting. So it includes a network of cell sites, and each of which has a base station that communicates with mobile devices over the airwaves or the radio frequency. Last is we have the core network. So what is a core network? So the core network is somewhat responsible for managing the overall operation of the network. So it includes routing traffic between different networks and providing advanced services such as calling, messaging, and data services. So the RAN is connected to the core network via a backhaul. So this backhaul may be microwave, satellite, fiber optics, and copper. So there's still a lot of consideration on what backhaul to use, but so much for that. So again, the core network is somewhat like the brain, the brain of our communication system. So again, to overview, we have the user terminal and the RAN radio access network. These two are connected via an air interface. And after that, we have our third component, which is the core network, which is the brain of the communication system. And the RAN or the radio access network is connected to the core network via a backhaul. Again. Okay, moving forward. Now let's have a little or grasp a little concept of the spectrum. So the spectrum is the fundamental asset that provides wireless connectivity. But how are we gonna understand what is a spectrum for those who are non-engineering professionals. So let's think of it. We have here a rainbow, right? So the rainbow has different colors. So we have a red, orange, yellow, green, blue, indigo, and violet. Now let's replace these colors with ranges of invisible waves. Hmm, that's the place with that. So this range of waves is what we call the radio spectrum. So we have here different kinds of waves like a radio wave, a microwave, an infrared, ultraviolet, X-ray, and so on. So for example, we have a piano. So in a piano, we have a low notes and high notes. So the low notes of in a piano, these are the low frequency waves. Well, the high notes are the high frequency waves. So as you play the piano with the different keys, so it's just like the radio waves. And in the radio spectrum, each wave has a different purposes. So this may be like for TV signals, for Wi-Fi, for mobile phones, and emergency services. So in a radio spectrum, it's just like a playground of for different technologies to share space. So it is organized that your Wi-Fi doesn't interfere with your radio station, and your phone can make calls without disrupting your neighbor's TV. Just imagine if we don't have that spectrum. So it will be a very chaotic environment for all of us, that there will be an interference with each uh product or something like that. So these waves or these radio waves carry information invisibly through the air, connecting devices, allowing us to watch videos, make calls, stay connected, like an invisible magic highway for information. So yeah, that's it. So the spectrum is measured in hertz, and and operators acquire license to use certain frequencies for a given period in return for paying annual fee, spectrum user fee, and the licenses normally is 10 to 20 years in duration. So this is not free. So there's an agency who really assign on what frequency do each unit use. Okay. Now let's move forward. So what are the cellular frequencies that is available here in the Philippines? So we have 450, 700 megahertz, 850, 900, 1800, 1900, 2000, 2100, 2300, 2500s, 3000s, and 3500s. Uh, as you can observe on your screen, there are two colors, like the red one and the blue one. And the red ones is for frequency division duplex, and the blue ones are the time division duplex. But before that, I think when I was in the telecommunication industry, these frequencies are used for the GSM, but some of these here are used for LTE, and the higher frequencies are used for the 5G network. So these two, the FDD, the frequency division duplex, and the time division duplex, are the modes of operation of of these frequencies. So there are two. So this first one is the frequency division duplex. So FDD is a duplexing technique that uses separate frequency bands for uplink and downlink communication. So for instance, so let's consider like this is a mobile scenario. So there will be a downlink. So for non-engineering term, these are your downloads. And there's also an uplink. So it's the upload. So in a downlink scenario, so the base station, you have a base station that transmit data to the user equipment. So you have here a base station, and it will transmit data to the user equipment over a specific frequency band. Let's say this band is around 900 megahertz. While the uplink, the user equipment is transmitting data back to the base stations using a different frequency band, let's say 1800 megahertz. So these two, the uplink, your uplink and downlink, are using two different frequency. That's why it's called frequency division duplex. But what does it do? So how it can help our communication? So it allows simultaneous communication in both direction. So this kind of duplexing is usually used or common for like 4G technology and 5G technology cellular networks that enables more efficient and reliable since they are like passing through two different technology. So it allows bidirectional communication between the two. So the next one we have is the time division duplex. So from the word itself, time. So the TDD stands for time division duplex. And here you can see here, uh, this one is, the blue one is downlink and the red one is the uplink. So it is a duplexing technique used in telco to transmit and receive signals on the same frequency. So if FDD transmit and receive in two different frequency, TDD transmit in the same or on the same frequency, but at a different time. So at a different time. So like for example, how am I gonna say that? Like for example, there's a there's a traffic light. So in a roadway or in a highway, there's a traffic light. So the traffic light is like allowing the traffic to flow um um efficiently. So in a TDD system, the TDD is like the traffic signal. So it alternates the flow. So you can go right the when the traffic light signals you go. So it allows the traffic to flow alternately in a lot of directions. But in TDD system, there are only two direction. One is uplink and one is downlink. So it alternates in each slot. So or in the first slot you have downlink, in the second slot you have uplink, the next one downlink, and so on and so forth. So that's how I differentiate the two modes of operation. So FDD have two different frequencies. TDD have one frequency, but alternating the direction or the two direction, which is the uplink and downlink in one frequency. Okay. Now, let me repeat again. So we have here a wireless telecommunication system going back. So the RAN is connected to the user terminals via air interface. And these RAN gives up to the user interface network coverage. So the RAN is connected to the core network via a backhaul. This may be copper, fiber, microwave, or satellite. And the core network is where everything happens. This is the brain of the system. But let's focus on the radio access network or the RAN. So again, the mobile network coverage comes from this thing, and the RAN is responsible for providing us the wireless connectivity required for mobile devices to connect to the core network and access these services like calling, data, and such. So it includes a network of cell sites, each of which has a base station that communicates with mobile devices. So the RAN is a part of the cellular network that is nearest to the subscribers, so you can see it around you. Really, you can see it around you. Like if you were traveling or just walking or passing by through a village or a highway or malls or beaches, there are a lot of RAN elements that create seamless and coverage and mobility. But think of it, like like back then when I was like traveling when I was still a kid and not taking engineering courses. So I may be curious of how are we stay connected while on the go or like running through some errands. Well, now that we understand that these RAN gives us the network coverage, so this is all thanks to the RAN, right? So next time you can clearly observe like going around or like traveling while you're on the train or on a bus, you can see them. So you can like imagine or think that these cell sites, oh, this is the thing that that's giving us signals so that we can connect from the other side of the globe or in the other side of the Philippines. So really all things to the RAN. So you can see here such an example of where you can see the RAN. So you can see it on the roadside, a few meters from the road actually. So on the province, you can see it sometimes on the top of the mountain, top of the hill. In beaches in Boracay, you can see this. Here in the city in Manila, you can see it on the rooftop. You can also see that beside on a wall of the buildings, but also you can see that inside the mall. So these small devices or equipments, these also gives you signals. This is part of the RAN, of the radio access network. So basically you can just see it everywhere. So that's the reason why we're connected whenever and wherever we are. But first, before we move forward with the radio access network, let's study the evolution of the mobile communication. So really it's just not so long ago, like 30 years or 20 years ago, there was still a lot of limitations when in terms of the communication, and we're just limited to radio antenna. And so that's what we call we have a lot of phone files, or we do telebabad on phone like what we see in the movies. So I was still in the planning of the Lord back then. So on the first generation in the 1990s, the first generation of telephone or mobile phone technology was introduced. But it's using analog signals to enable just basic voice calling. So you can only do on your phones is to call. And imagine that these early mobile phones were very large and expensive. So you're really bringing uh large devices while you're on the go. So if you can if you can still remember like those in the movies, there are like people who have died and really bring these large phones, these large equipments and put it on their side. And that's those are the cool kids back then. And but bringing these large devices, you have a very limited network coverage back then, and there's a lot of limitation. But despite of all of that, this first generation of mobile telephone leads to a lot of upgrades and developments in the mobile community or communication industry nowadays. So that really begins into like moving to the second generation of the mobile phones, mobile communication. So this 2G was introduced early in the 1990s, and really enables us to do voice calling and texting services. So it is already using on digital signaling and allowed us for more efficient use of radio spectrum than the previous analog system. So this is already using GSM or global system for mobile communication technology. So that's the reason why we can do basic callings and texting. But so much for that. You can still remember the 3210 phones and some keypad phones that we're using back then. And here in the Philippines, we were tagged as the texting capital of the world. So there were a lot of like clan meetups. We do group messages. We also like try to send messages earlier 3 days or 2 days before the Christmas, so that we we can send them messages, because it's really hard to do the transmitting and the receiving of messages if there's a really high traffic of in the communication system back then, because there's a lot of people who's using the services, especially on peak seasons or on in the holidays. So then we always move forward and do the upgrades. So then there became the third generation of mobile communication. So this was introduced in the 2000s using UMTS technology. So this is Universal Mobile Telecommunication System. 3G brought us faster data speeds, enabling more advanced services like mobile internet, video calls, multimedia messages, and really supported a better voice quality and allowed us to for simultaneous voice and data services. So 3G was really helpful in our communication system back then. But there's a really a growing demand for communication as years pass by. So it leads to the innovation of the fourth generation of mobile communication, late, uh, which was introduced back in 2010. So it brought even faster data speeds, better network capacity, and more reliable coverage. So this is what we're using in the present. We also have 4G plus. So the 4G enabled services like streaming video, online gaming, mobile payments, and paved the way for Internet of Things and other emerging technologies. So I think we can do Mobile Legends or such things like Tetris or Dota, and so much of online things and stuffs. But now, since just like what I've told, we are an upgrading tree and developing a lot in the communication industry as years goes by. We have now is the fifth generation of mobile communication. So it promises to be even faster and more capable than 4G. So the data speeds that are up to 100 times faster than 4G, and the ability to support a massive number of devices at once. So this technology is expected to enable new and innovative services like augmented reality, autonomous vehicles, and smart cities, and to transform the way we live and work. So um, I think I already tested a 5G signal uh back then, and it really have a faster data that I was surprised when I first tested it out. So it's really a good advancement in the communication technology. So yeah, that's it. But now, since we're just talking about RAN, so this different generation of technology have different names for each radio access network that are used in different generation for mobile communication. So first, we have the second generation, which do SMS, texting, and voice calling. So this second generation, the RAN for this was named GERAN, or the GSM Edge Radio Access Network. So the BTS, or base transceiver station, is what we're using to like really gives coverage to the users. So next we have is 3G, or which do mobile internet and video calling. Uh, the base station for that is the Node B, and the RAN was named UTLAN, or the UMTS Terrestrial Radio Access Network. For 4G, we have Inode for high-speed internet and mobile broadband, and the RAN is named EUTRAN, or Evolved UMTS Terrestrial Radio Access Network. And for 5G, we have the different use cases for that, which is EMBB or LLC, MMTC, which will be discussed in the future. So the RAN is named Next Generation Radio Access Network. So we have JARAN, UTRAN, EUTRAN, and NGRAN. So take note of these names. So RAN has its own name for every generation of cellular mobile telecommunication, but all have the same working principle. That's right, that's true. So now let's have a look at different RAN components. So we have here in a RAN component, we have the RU, the BBU. The RU and the BBU is connected by a front hole, and 4G core network, the core network is connected to the BBU. This is and the RU by a backhaul. So we have here the user terminal or the user equipment. So now let's try to break down what are the different components that the radio access network has. First, first we have is the tower structure. So this is the physical structure that supports the RAN components, such as the antennas and the cables. So, so here, these tower structure supports one is the panel antennas. So the antennas is responsible for transmitting and receiving radio signals between the mobile devices and the RAN component. So that's the keyword: transmit and receive radio signals. Next one is we have the radio remote unit. So the RRU is one of the critical components of the RAN system, as it is responsible for like converting radio signals received by the antenna system into digital signals that can be processed by the BBU. So the RRU again, it converts the radio signal received into digital signals. And these digital signals will be converted by the baseband unit or the BBU. But first, before that, we go to the BBU. So these RAN components are connected by jumper cables and a lot of different cables, which is made of coaxial or fiber optic materials. So now we have is the baseband unit. So what is a baseband unit? So this one is responsible for processing the digital signals received from the RRU and transmit them to the core network. The BBU is typically located at the bottom of the tower structure, at the bottom, near the outdoor cabinet. So this is the outer cabinet. So near that thing. So this RRU and this BBU is connected in by a standard protocol we call the CPRI. So the CPRI transmit the digital signals between the RRU and the BBU. So it really ensures the signals are transmitted quickly and efficiently without any loss or degradation in quality. So this is the transmission. This is the transmission component of a radio access network. So, but also don't forget that it also has a transmission. So here we use a microwave antenna, but this can be of fiber optics and such. So there are different types of towers. So first one is we have the four-legged or the self-support tower. So the four-legged is generally constructed with various sizes and for of angles for heights ranging from 45 to 106 meters. So this is made to support heavy duty or heavy equipments attaching microwave imposed by attaching microwave dishes and mounting sector antennas. So as you can see here in the example that there's a lot of components in this kind of tower. So it really a lot of holds a lot of accessories, including a different platform, a brackets, lighting system, climbing ladder, safety cage, cable ladder, utility mounted poles. It also have antennas, and these equipments is no joke. These are really heavy equipments, and imagine that it's all supported by this tower. So the recommended height for this kind of tower is of 45, 60, 90, and 100 meters, and suitable for single and multiple operator usage as a trunk side. So next we have is the three-legged self-support tower. So this one is a lattice, and it is a freestanding vertical tower with rectangular and triangular bases. So it is favorable in such places that involves mounting panels or dish antennas. So this is mostly used by electricity for electricity transmission, cell or radio, or observation tower. The next one we have is a guide tower. So this is a a really slender steel structure with steel cables in the ground. So these are the steel cables. So if you saw this kind of tower, you usually saw this in a lot of places. So this is commonly used in the tower industry because they provide the greatest strength and most efficient and are easy to install. Next, we have is a monopole tower. So by the word itself, you only have a monopole tower. It's a single pole. So its elementary design reduces visual impact and is relatively simple to build. So tower developers favor this kind of tower. So next one is a rooftop tower. So in a rooftop, there's like two kinds, which is the rooftop pole and the rooftop bipods. So the rooftop bipods is usually range from 3 meters to 12 meters, and it holds 3 to 4 antenna panels. While the it if it's a pole, its height is from 3 to 6 meters, and it only holds us. It is used for mounting one or a single antenna. So you usually see this here in Manila. So there's a lot. If you're riding a train, you will see a lot of these kind of towers on the rooftops. So these two, we also have wall mount sites. So this is relatively uh, light cell site installed in the walls of the buildings with brackets. So if you're just wandering around, you can look on the different buildings and you will see a lot of this. Some are in camouflage. Next is cell site on wheels. So these are telecom infrastructure placed on trailers approved for road use and towed by heavy goods vehicles for loads of up to 3,500 kilograms. So these kind of cell sites are usually used at concerts, events, conferences. So you will see a lot of this deployed during those kind of events. This is called Cow for Globe and Meow for Smart. I don't know what they use in detail, but those are the things that I know. So the next one we have is a camouflage site. So a camouflage site from the word itself, it's a camouflage. So it's stealth tower and a monopole tower, but in disguise. So they are in disguise. We cannot really see that there's a cell site in there. So so they reduce the visual impact of the actual tower, and there are different variations of stealth tower, like a raw leaf, a tree, a palm tree, a water tower, a flagpole, a light tower, a billboard. So here you can see um examples for that. There are also deployed camouflage sites here in the Philippines, but it's for you to look. So next one is a water tower, and it's run on wheel with cell tower entities on top of it. So this tower is conducive financially to communication companies because the company does not have to spend thousands of dollars on building a new tower structure. So water tower companies usually negotiate rental prices with the tower companies or the wireless carrier to allow companies to put their equipment on top of their towers. This agreement mutually benefits both parties and allow for a multi-use tower. So you can see here in the example, they build these they put the components of the cell site or the RAN on the top of a water tower. So that's basically why it's called a water tower. So lastly, we have an in-building solutions or the IBS. So it is it is a site where the components are meant for indoor usage. So you usually see this inside a mall, hotels, government facilities, buildings, offices. This is kind of the solution that I was doing back then. I do designing of these, and really this is one of the amazing job of being an engineer. So in concept, if you have a two-floor building, so the radio unit, there's a radio unit wherein all of the equipments are there. It is connected via cables, and there are a lot of splitters that was used in order for to connect the different antennas. You have two kinds of antennas that were used, so omni and panel antennas. So that's basically it. So it gives up signals inside the building. Next one we have is a small cell or a picocell site. So this kind of cell site is connected by fiber optics cable and mounted to an already made structure like a light or a utility pole. So you can also see this at some posts or at some poles around Makati or BGC. So next is the portable or 5/8 cell site. So Singtel released a portable cell site to serve in disaster situations that are small enough to fit into a suitcase, giving first responders another communication tool when regular communication channels are offline. So imagine, right? You'll be bringing cell sites wherever and wherever you are. So this will be a very useful tool for us to stay connected, especially on like remote areas, right? So equipment from traditional vendors, remote radio units. So this RRU is a radio transceiver that communicates with mobile devices over the airwaves and is located remotely from the baseband processing unit. So there are different RRUs. So it depends on the technology that we're using. So this RRU is a radio transceiver, so it communicates with mobile devices over the airwaves, so and located remotely from the baseband processing unit. So this is in building in an IBS. This is usually outside the radio room or inside, but it's still there's a wall between this and the equipments. In a RAN, it is usually located near the antenna site or connected to the baseband processing unit via a fiber optic. So this equipment or component plays a critical role in the operation of the RAN system. So that's it. Next we have is the CPRI, or the Common Public Radio Interface. So this it is a key technology used in modern radio access networks systems to like transmit data from the RRU and the BBU. So it enables high-speed transmission of data over fiber optics cable, allowing the RRU and the BBU to communicate with each other. So imagine it as the brain. The BBU is the brain, and this was the bronze. So they have their own language, these two, and that is the CPRI. So now we have is the baseband unit. So the baseband unit plays a critical component or role in the RAN. So this BBU is responsible for processing and managing the data that is transmitted to and from our mobile devices. So essentially, this BBU is the brain of the RAN. So it controls the flow of data and ensuring that everything operates smoothly. So it is like responsible again for processing the digital signals received from the RRU and converting them into analog signals that can be transmitted over the airwaves, and responsible for receiving the analog signals from mobile devices and converting them back into the digital signals that can be processed by the RAN. So it really plays a really essential role or critical role in the RAN. So without it, I think we won't be for connected to the wider network, and we cannot access a wide range of the services that we're using today. Okay. So The radio access network is often divided into different layers. So each layer is responsible for different functions or aspects in the system. And one of the common ways to really conceptualize these layers is through the OSI, or the Open Systems Interconnection Model. So it is a conceptual framework that describes the communication functions of a telecommunication or computing system. I think most of the participants here are electronics engineer, and we're all familiar with the OSI layer. So the OSI model is a set of concepts that describe and standardize how a computer of or a telecommunication system communicates regardless of how is it built or what technology it uses. So here we have is the OSI model. So it has 7 layers. Each layer represents a different aspect of communication between devices on a network. So these layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So, so these three, the first three layers, like physical data link and network layer, this is mainly done by the two units in the RAN system, which is the base BBU and the RRU. So, but before we move on for in those three, let me give you an overview of these 7 layers. So the first one we have is the physical layer. So this physical layer is responsible for the transmission and reception of raw data over a physical medium. So this may be like for example, we have is the fiber optics and the copper. So the next one is we have a data link layer. So this data link layer is responsible for the reliable transmission of data over a shared physical medium. So this use of protocols such as Ethernet or Wi-Fi. The third one we have is the network layer. So this is mostly responsible of routing data between different devices on the network. So using protocols such as IP or MPLS. The fourth one we have is transport layer. So we're already here. So this layer is responsible for like ensuring reliable and efficient data transfer between the devices on the network. So this use protocols such as the TCP or the UDP. And the fifth one we have is the session layer. So this layer is responsible for establishing I think establishing and managing communication session between the devices on a network. So this layer uses protocols such as the RPC and the NetBIOS. On the sixth layer, we have is the rest is presentation layer. So this one is mainly responsible for formatting and presenting the data to be transmitted over a network. While the last but not the least is the application layer. So it is responsible for providing high level services and applications to our users. So these, for example, it's for email, web browsing, and voice calling. So really, each layer has its own functions, and each function plays a critical role in the operation of the radio access network. So take note of these seven, but to really embrace our ECE being an electronics engineer. So we have here mnemonics that we usually use um during college. So we have all people seem to need data processing, but really when I was in college I use ang pulis sa tulay nadapa. So you can just really share what mnemonics do you use just to remember all of these layers. So yeah, that's it. So now let's try to map these different components of the RAN system. But we will mainly focus on these three. So the first one is the physical layer, just like what I've said. It is responsible for the transmission and reception of the raw data over a physical medium. So physical. So it is an example, just I told earlier was copper and fiber optics cables. So this layer includes the tower structure, the antenna systems, and cables that transmit the wireless signals to and from our mobile devices. Next one we have is the data link layer, which is responsible for reliable transmission of data over a shared physical medium. So it really use protocols such as the Ethernet or the Wi-Fi. But in a RAN perspective, this includes the RRU, which is the remote radio unit, communicates the mobile devices with over the airwaves, and the BBU again, which processes and manages the data transmitted by the RRU. The last one we have is the network layer. So the network layer is responsible for like routing data between the devices on a network. So this use protocols such as IP and MPLS, but this layer really includes the network gateways which connect the RAN to the core network and other external networks. So mapping these in the OSI model to the different components of the RAN, we can better understand the role of each layer and how they work together to provide reliable and efficient wireless connectivity for our mobile devices. So this is really an essential knowledge for network engineers and telecommunication professionals who near or works with RAN systems on their daily life or on a daily basis. Now, let's try to break it down more. So the physical layer is the first layer in the OSI model, again, which is responsible for the transmission and the reception of our raw data. So this is uh like the front hole and the back holes. These are the examples for that. That is the physical layer. So in a RAN system, one of the key functions of this physical layer is to convert the radio frequency signals from analog to digital to analog. So we have here the physical layer which converts radio signals from analog to digital and digital to analog. Then we also have here the data link and the network layer. So in the data link layer, so in the RAN system, it includes PDCP or packet data convergence protocol, the RLC, which is the radio link control, and the MAC, which is the medium access protocols. So these three are used to segment, reassemble, and manage the data transmitted between the RRU and the BBU. So last is we have the network layer, which includes the RRC here, the RRC, which is responsible for controlling the access to the radio resources of the RAN. So overall, so the physical layer, the data link layer, and the network layer um, is a key in the operation of the RAN systems, enabling mobile devices to connect to the wider network of services. So through these use of these RF transmitters and data link layers, network layers, the RAN system or the radio access network system is able to reliably and efficiently transmit data between devices, ensuring that users have access to the wireless connectivity that they need.